All right, so here's e to the ix plus e to the 2ix plus e to the 3ix.
So we sort of double kinked it now.
Yeah, but you had an interesting idea, but we still have lots of room to change this around.
But how could we create a kink on the other side?
Yeah, that's a good thing to wonder about.
What if we added a completely different variable?
Like what?
Like maybe y.
Ah, okay. That is a very interesting idea. It turns out that that's going to be tricky to graph. So right now I want to try to, just for today, think of these in one variable. Because complex numbers, when you have two variables,
Are harder?
no, they just get a little bit more
Complicated?
funny enough. But there's other ways we can modify this.
Well, what if we use like imaginary numbers like I?
Well, we're using I.
Yeah, we're going to stick to real numbers for going like from 0 to 200.
Or maybe we could... Well, we already tried going like the pies.
Mm-hmm.
So what else could we do aside from adding on variables? Or adding on systems?
Okay. Well, one thing we could do is instead we could multiply these on the outside by some number. So I could multiply by 2 here.
Times 2.
2 times that. What do you think is going to happen there?
Maybe it'll like make another pattern here. Like,
It's a different... It's sort of like the kink isn't there. Like, you have the same pattern, but there's no kink.
Uh-huh. What now?
Maybe multiply some other things, like the third variable we added.
Okay.
Multiply that by 3.
Multiply by 3. Oops, not 38. 3 times.
ooh,
Hey, we did create is that actually a perfect circle?
we did create a
That
looks like a perfect
I
circle.
don't think it is, because you have minus 2 here, and then you don't quite get to minus 2 here. You're not getting to 2 or 2 on the y-axis. But still, looks like a pretty cool pattern. Sort of looks like an eye.
Yeah.
Well, now we're gonna. Maybe we could like multiply something by pi, and see what happens. Maybe we'd get a perfect circle because it's just off a perfect circle.
Okay. Interesting idea. How about this one by pi?
See, now we're getting close.
We're still not at a perfect circle. It got a little closer.
But this one
But
went
then we went
above
too far that way. Huh. So how can we change all the 3 that were imperfect and leave the one that was good there?
Yeah. Well, I would say just keep playing around.
Let's see. What? Well, maybe we could add like I times something big.
All right. Like what? Like here?
Maybe like I times 100.
Whoa.
Wait. The items. Yeah. Then we get chaos.
Crazy thing.
Just chaotic now.
Yeah, we probably need to go a little more.
Whoa, completely black in the middle.
Yeah, the big numbers are going to make it go a little nutty. But
We're at
maybe if we
10.
go to 10, oops, still a little nutty.
Well, I mean,
But-
we're at
2.
2,000.
We're getting sort of.
Maybe 5.
Oops, sorry for bumping the camera there.
Like 2 circles interlocking. It's interesting.
Maybe because we're at 2,000.
200. Oh, just simplifies down to that.
Yeah. So I think you're right. I think going up to 2,000, there was little errors in the calculations that added up to produce a little bit of chaos, probably. But this is a pretty interesting looking one.
Yeah.
Yeah, you have like you've got like 2 of those kinks interlocking.
And then you have an eye. An evil eye.
An evil eye looking at you. What are some things you can tell me about this shape? This one's actually pretty neat looking.
Well, it looks like there's 2 interlocking circles.
Oh, it also looks like it's symmetrical over the x-axis.
And the y-axis.
Yeah. Is that called fourfold symmetry?
Hmm.
Like if you if you cut it along the x-axis and cut it along the y-axis, you get the same piece 4 times.
Very interesting.
And what if you cut it along like the diagonal, the perfect diagonal between this, so you get two 45-degree angles?
Do you think
And
it
then
has
you get it
symmetry
again.
that way?
Maybe.
I think it would be like mirror images of each other.
Cutting it at a 45-degree angle?
Well, cutting it at a 45-degree angle. Actually, it looks like they could be symmetrical that way too.
Yeah, I'm not convinced that it is, but I'm not sure.
No, can you like rotate it 45 to like can you rotate the entire shape with like a function?
You could actually. I don't think I could do that quickly though. But you could. Probably would just be easier to pick up the computer monitor and tilt it. But I'm not too keen to do that either.
No.
All right. Well, let me show you now one of the neat diagrams from Ferris's book. Okay.
Alright.